Welcome to 24 Hours of PaaS, 20 years of past learnings, and future vision. We are excited you can join us today for Allan Hirt's session, a look into the past and the future of availability and infrastructure for SQL Server deployment. This 24 Hours of PaaS consists of 24 consecutive live webinars delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when these are available. My name is Javier Villegas, DBA Manager at Mediterranean Shipping Company, Microsoft MVP Data Platform, and member of SQL Argentina PaaS community. I have a few introductory slides before I hand over the reins to Allan. If you require technical assistance, please type your request into the question panel located on the right side of your screen and someone will assist you. This question panel is also where you may ask any questions through the presentation. Feel free to enter your questions at any time, and once we get the Q&A portion of the session, I will read your question aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation windows. Please note that there will be a short evaluation at the end of the session, which will pop up right after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. I'd like to take a moment to thank our sponsors, Microsoft and Intel. The station of 24 Hours of PaaS wouldn't be possible without their generous support, and they are the reason this event is available free of charge. If you would like to learn more about Microsoft or Intel and sign up for the information on how they can help you, please visit the sponsored page of the 24 Hours of PaaS website. Keep learning all the year long with PaaS. Visit paas.org and check out all the free educational resources available to PaaS members. Also, don't forget that PaaS Summit 2019 will be happening on November 5th in Seattle, Washington. Head over to paassummit.com and register today. And without further ado, here's Allan with a look into the past and the future of availability and infrastructure for SQL Server deployment. Allan?
Thank you so much. Welcome, good morning, good afternoon, or good evening, everyone, depending on where you are. For the next hour or so, or a little less than, I'm going to talk to you about sort of where we've come from, where we are today, and where we're going in terms of both infrastructure and the Windows side of things, as well as where we are from an overall availability standpoint in the OS platform and from a SQL Server perspective. Now, why am I sort of uniquely qualified to talk to you about this? Just a little about me. I've been working with SQL Server since 1992. I've been working with clustering since its Wolfpack days in the late 90s, and when I worked at Microsoft, I did things like the SQL Server 2000 SQL Server 2000 failover cluster instance white paper, which got me started on a lot of what I do today. So I've been working with high availability now for over 20 years. I'm currently a dual Microsoft MVP, both on the Windows side of the house as well as SQL Server, and I'm also VMware vExpert. So I see things at not just the Microsoft level, but sort of how all my customers deploy things. We're going to talk through a bunch of stuff that's related to that in this talk. All right. So we're talking about 20 years of PaaS as an organization. So I kind of went back and I looked at, what was going on in 1999. I sort of stayed away from history and politics because that's always controversial. But I also picked a few things here that were interesting to me. There's one that I didn't put on here that is really relevant to me, which is the band Styx released their new album and last album with Dennis DeYoung in 1999 called Brave New World. They basically broke up, or should we say Dennis was kicked out of the band then. Those of you who know me know I'm a big music guy. So that's actually a picture from my SACD player, or my Super Audio CD player, the Sony SCD XA 5400ES. So the SACD is 20 years old this year. Some of you might remember when there was a whole Metallica and Napster thing, going on. Those of you who are into movies and are sort of Star Wars nerds, Phantom Menace came out. I know not everybody's favorite movie, but from a technology standpoint, think of how far we've come. And we're big in cell phones these days, but the BlackBerry was just introduced in 1999, and RIM today is not obviously really a big thing. Things like TLS and the internet TLS was just invented, and the internet was not the behemoth it is now. That basically, we would have never had the cloud in 1999, right? And because we're database people, Microsoft literally had just purchased access to incorporate into Office. That's how long time has passed. Okay. But more germane to what I am going to be talking about here, things looked very different from a server perspective. We were still in a 32-bit world from a Windows perspective. And things like the Deck Alpha, I remember, implementing it customers, and, for quite a while we were using things like Deck Alpha with NT4. And we'll talk about 64-bit in a little bit. But, servers also had like multiple NIC cards with single ports. We had hard disk drives, this stuff of platters and heads. But in terms of capacity, think about, we can get a thumb drive today that has, good capacity, a terabyte even, 2 terabytes, whatever. Our hard drives back then were about 20 gigs, maybe a little bit more, maybe a little bit less at max capacity. And we really didn't have anything that, I think 15K came in about 2 or 3 years later. SSDs were not a thing yet. So we're talking, you would need a lot of physical drives that were rated to get the performance you needed, let alone availability. So RAID was really big in terms of sort of getting what you needed out of your storage back then. And we'll see how that comes into play today. Now, I've been saying this when I chat with people, but this sort of this slide here is going to put into perspective where we've come from I would say 50,000 foot view. So when we were deploying servers back in, the late 90s, early 2000s, everybody owned their own data center for the most part. Even if it was in a closet, everybody owned their own data center. That's including the hardware, the racks, everything, right? Everything was also physical. Then there came a point a few years later where the trend towards co-location, meaning you went to somebody else's data center, you had your own maybe set of racks that were locked, but it was there, and they provided the plumbing. They generally at that point didn't provide a lot of services to you except basically electricity and networking and that kind of stuff, right? Then, as we went further on, so think about mid-2000s now. I wrote a white paper for Microsoft on consolidation around then, and consolidation was a big thing in the mid-2000s because at that point we'd had SQL Server 2000 for about 5 years or so, and a lot of people had deployed a lot of stuff, especially 2-node failover cluster instances, but they had a lot of sort of, shall we say, spare capacity hanging around. So we had a big trend towards consolidation. Then a few years later is when virtualization really started to take off. It didn't get really hot until about 2009 or so. I remember sitting on a panel actually at Past Summit, which has celebrated its 20th year, about 12 years ago. And everybody's like, no, we're not going to virtualize. It stinks. Well, we're going to talk about virtualization here in a minute, but that isn't the case anymore, right? Then fast forward to the past couple of years. the public cloud, and some people are tired of the word cloud, but the cloud's here to stay, folks, and we're looking at moving things up towards the cloud. Not everybody and not in every case. And I'm going to talk about that a little bit as well. But the question is, where are we going in the future? Right now, we don't know. I mean, right now, it's people are looking towards a cloud, but is there something after the public cloud, right? And none of this means that you're still not going to do physical, which we're also going to talk about as well, because there's still trends that would dictate where you would do physical. But this is where we've come. And if you really want to think about it, things like the public cloud is kind of like co-location for VMs. So it's kind of interesting. Okay. I wanted to specifically talk about virtualization because really, to me, as a person who's an infrastructure guy and has helped customers for 20 years or so, virtualization has been very disruptive because where we used to have to order hardware and rack and stack it, all this stuff that took time and you needed a bunch of lead time to get things done, you could spin up with a right click of the mouse. And now that the capacity is there, part of the reason virtualization didn't take hold for a while was that the early versions of hypervisors limited the size of virtual machine that you could configure. No really big workload is going to work on a 2 or 4 or 8 vCPU VM. But now that we basically can have crazy sizes with our VMs that are pretty much the same as our physical host underneath it, it doesn't make sense in many cases to not virtualize, right? And as I mentioned, infrastructure as a service, or IaaS, up in the cloud is just a VM running on a hypervisor. So it's really no different than what you're doing on premises, except you're not controlling sort of the underlying platform. You're just telling it, I want a VM of X size with this amount of storage, and please go deploy that. Now, with my customers in my day job, we still deploy physical servers too. We aren't just exclusively cloud. We're not just doing virtualization. There are, very large big iron systems that I'm helping customers deploy that need those things. We're going to talk about some of those advancements, some of which were actually announced this week by Intel, who also had a session yesterday where they talked about Optane, that if you need certain things, physical is still the way to go. Unfortunately, where things like virtualization have made things harder for DBAs is things like troubleshooting, because from your perspective as a DBA, right, or your sysadmin, whatever your role is, when you're remote desktop into a virtual machine, it looks, acts, and feels like you're on a regular server, as it should. That's what it does. But if you're on a host with, say, another 20 VMs and you're having performance issues, is your performance issue the query? Is it the inside the VM, is something misconfigured there? Is it at the hypervisor layer? Are you getting pressure from somewhere else? So now you need to diagnose sometimes in another layer. So virtualization's changed how we do things like troubleshooting and performance tuning. So again, really interesting, because 10 years ago, virtualization wasn't that huge, whereas now, if you think about your own environments, I bet most of you are at least 70, 80, 90% virtualized in your environments. Just a quick overview in putting, and I have a similar SQL Server slide later, just to see where we've been in the past 20 years of Windows Server. At that point, we had Windows NT 4.0 Server, which was released in 97, I believe. And the little slashes there represent extended support. So Microsoft has a general support rule for their platforms. It's 5 years of mainstream support, 5 years of extended support. So here, those are basically your life cycles of all your server platforms over the past 10 years, or sorry, 20 years, I should say. And it's interesting to look at how much Microsoft has released, right? And put this in context of where maybe you are today. And for example, where Microsoft has talked about of getting off of, 2008 and 2008 R2. Oh, hey, I skipped an OS release. Huh. I noticed I didn't put SQL Server 2008 Windows Server 2008 R2 on here. But interestingly enough, right, those are going out of full support, including extended support, very soon. And a lot of you, I bet, still have a lot of Windows Server 2008 or 2008 R2, possibly even running SQL Server 2012, which, again, it isn't that old, but and it's a great release. But if we really think about it, SQL Server 2012 at this point's 7 years old. So it's a bit long in the tooth. I'm not saying you have to upgrade, and we'll talk a little bit about that, how all this modern stuff has made this easier and harder for the case for upgrading. But I just thought this was kind of an interesting 20-year look at things, right? But what has changed in Windows Server? And obviously a lot has, and I can't touch on every little aspect, but I wanted to cover some of the aspects that I found notable. Now, when I started this talk, I mentioned how we were in a 32-bit world. We didn't see any 64-bit stuff until later in the cycle for Windows Server 2000 and SQL Server 2000. We had kind of jokingly called it at the time SQL Server 2003 because it came out around then. And the Itanium was really the first major 64-bit platform that took hold and had widespread adoption. That was really in play till SQL Server 2008 R2 and Windows Server 2008 R2, where it was sunsetted. And the reason for that was the x64 stuff, which came in Windows Server 2003 R2 and was fully supported in SQL Server 2005, really became the 64-bit platform from Intel, or the x86 platform, if you will, right? And we still call it x86 sometimes, but it's really a 64-bit platform because nobody's really deploying a 32-bit OS. And, trivia-wise, there hasn't been a 32-bit OS from Windows in over 10 years. I believe it was Windows Server 2008, maybe 2008 R2. That was the last 32-bit OS release. SQL Server persisted on a little bit longer in terms of releasing a 32-bit server version, but we haven't had a 32-bit world for a long time, so that's pretty significant. These days we've gone from servers where I remember the days, if you had 16 gigs of memory, you had a lot. I've got 32 gigs of memory in my laptop now, right? We're talking about servers today that can support up to 24 terabytes. That's a pretty amazing leap in the course of 20 years. I know most of you who are doing virtualization aren't using it, but having a free hypervisor built in is still pretty cool. I was talking about this with my business partner, and I was sort of asking him from his perspective some of his stuff. And he came up with this next bullet point here of Windows Update. And, I added Windows Server Update Services, or WSUS, which kind of supports that. And I know, personally, I don't like to, and we were sort of having a conversation on Twitter yesterday, actually, where this kind of came up. I don't like to automatically update servers, especially in a mission-critical environment. I like to have some control with my customers. But if you think about it, the idea that updates can get pushed down to you automatically and keep you secure and updated wasn't a thing 20 years ago. I mean, a lot of that has to do with the internet. I mean, it's a pretty amazing thing to think about, that you could be a small business or a large business, but your servers can get updated, or at least get the updates pushed down to you in a way that, if there's a major security update, you might not have to think about it. Now, again, is it the best implementation for your company? That's a different question. But it's a pretty significant advancement in how we think about patching our servers. Things like the Trustworthy Computing Initiative, which are still in effect today at Microsoft, had a really big impact on secure by design. And think about it, in this world of data breaches, Microsoft designs their products by and large to be secure by design. And that was put in roughly in the 2000 to 2003 timeframe. So that again, to me, pretty significant. And we weren't in the world where we had a lot of data breaches that like we have today. And finally, something that might be near and dear to some of you on this webcast heart is PowerShell. So those of you that use dbatools.io, shout out to those folks. They wouldn't be doing what they do if PowerShell didn't come into the product. And, with SQL Server, we really didn't get any PowerShell stuff until around that we could use until around 2008 R2, 2008 R2, when we started to do clustering. So kind of interesting. All right, let's get more into the infrastructure stuff that I love. Now, the reason I talk about this stuff in Windows Server is that while I'm a SQL Server guy at heart, I also deal with everything that sits around it. And that's how we get platforms that scale and are available. All that stuff needs to be right. Now, in this modern world of SQL Server, the thing that's going to matter most and is getting to be even more important, even if you're not viewing it that way, is networking. Because think about it, you've got an always-on availability group, and you want it to be synchronous. You have, in your local data center, servers A and servers B with 2 instances participating in an availability group, and you've got a really busy application. You're sometimes doing a very large index rebuild. Well, that gets pushed across the wire. And if you're running on an old, say, 1 gigabit network, which is 125 megasecond, that you go, well, 125 megasecond doesn't seem so bad. But the reality is that pipe is shared, right? So if you're seeing things like lagging, sometimes it's networking, sometimes it's storage, maybe it's something else. But the way we talk between things, the way the cloud works, that's generally all networking. It's not like, in many cases, local storage or other things that are attached to a server. There are cases where that's true in the cloud, but by and large, a lot of this stuff is powered by networking. Your pipes need to get bigger. So one of the things that I strongly recommend is that, if you look at where you are today, 10 gigabit at this point should be the sort of minimum entry into the world of networking these days. Now, there's some, unknown guy that you guys may have heard of named Jeffrey Snowser. He's a, sort of unknown guy from Microsoft. And, that tweet there came up recently, well, last year, never bet against Ethernet. And the other tweet that I'm pointing out there is that there's this other concept called RDMA, or Remote Direct Memory Access. That's really fast networking. We've implemented with customers. It can be used in certain SQL Server scenarios, like FCIs. But basically, it's a way to speed up your networking such that you basically bypass the traditional CPU stack. And these days, where you can have speeds of, up to, say, 200 gigabit, Intel this week talked about a card that they're releasing, which is 100 gigabit. I mean, things like RDMA make that extra bit of difference. And I'm hoping that SQL Server does eventually support RDMA. I have a blog post on that. But networking is pretty amazing these days. We're beyond, just little networks. Now let's talk about drives, okay? So we already kind of talked about hard disk drives a little bit earlier, but we kind of plateaued around the speed of 15K. There are physical limitations in the way that things are designed that really going beyond 15K would be quite difficult. You've seen capacity go up, so the density of the platter is increasing, but the cost of getting, say, better performance if they made, say, a 30K drive, but the heat and the power all needed for that probably wouldn't be worth it. I would say, just like virtualization transformed physical server deployments into something else, SSDs or solid state disks transformed the world of storage. Now, I got my first SSD in, I believe it was the Vio G12 from Japan laptop around 2004 or 2000, probably about 2005, I would think. It was a 32 gig SSD, and it was crazy expensive. It made the price of the laptop go up insanely. These days I've got in my laptop a 2 terabyte one, and you can get bigger ones for enterprise class. Now, there are different flavors of SSD. It's not just traditional drive form. It's also those things that look like gum sticks. Those are NVMe drives, and those are really, really fast. But and the thing about SSDs is there's two components that make it so good. It's how the memory is done, and there are different types of memory. There's NAND and a few others. But there's also, and that's what gives you your density, your storage. But the thing that controls your performance is the controller on it. And all controllers are not created equal. So that's why in the case of enterprise drives, sometimes they are different. Sometimes they're the same. But in general, if you're doing things in the enterprise space, I always recommend you get enterprise ones, mainly especially because of things like the guarantees and warranties and things like that. But sometimes there is actually a difference. Where we're going, and there were big announcements, and again, I mentioned this a little bit earlier, there was a session on, I believe, on yesterday's 24-hour edition of this 24 hours past with Intel Optane. And that's all this persistent memory stuff. So if you're still doing physical servers, persistent memory is going to get really interesting. I was actually looking at Intel's site with the Optane, and the PMEM stuff is in 3 flavors, at least that Intel sells. It's 128, 256, and 512 gig drives. So depending on your server configuration, we were actually configuring servers for a customer last year from a vendor I'm not going to name because pretty much everybody's doing it, but I found it cool that they had PMEM slots in there. So PMEM is a real deal. So, you could get, terabytes of storage on something that looks like a memory DIMM and the reason it's so much better than even SSDs is that it's literally the speed of bus and memory. And that's a huge leap over even NVMe, right? But where does this all mean for things like virtualization and the public cloud? Now, when we're talking about virtualization, again, it was transformative, and all this physical stuff I talked about sits underneath. The same is true for the public cloud. The challenge that we have is that when a disk is carved out, it's basically just a file sitting on an OS disk. So in the case of VMware, it's a VMDK. In the case of Hyper-V, it's a VHDX file. You can do pass-through in virtualization. You can have actual access to the physical disk, but generally that's a harder configuration. Now, up in the public cloud, I have a picture here. Let me zoom in on this really quickly. you basically buy your storage based on IOPS. And sometimes you have to aggregate and do things like storage spaces to get the complete IOPS you need. Now in Azure, for example, something like Ultra SSD, which is not pictured here, might take care of that for you. But you really need to think about how it's different, because underneath is all the stuff I talked about. But when you're carving it up, you need to think about it in terms of how you're using it. So it's a drive, but it's not really a drive, right? But in terms of how we've implemented storage, we also need to sort of take a 50,000-foot view and take what I just talked about and how do we deploy this stuff for SQL Server. So when I started out, everything, the late 90s, mid to late 90s, everything was local storage for the most part. There was no real network stuff. And SQL Server, to be honest with you, didn't work really well with network stuff. There used to be an infamous KB article out there that talked about never use network storage with SQL Server, right? Then we got into the world of direct attached storage, which is by and large how we did clustering in the late 90s through about almost mid 2000s, give or take, right? So direct DAS was huge. There was all these things where how you carved it up and how you did RAID, and it was always interesting. It was always an adventure. The hard SCSI resets were a challenge as well. Clustering fixed that later on. We'll talk about that in a bit. SANs, while they were introduced in the late 90s, didn't really become a big thing until, I'd say, starting about 2003, 2004, when the price started to come down. And SANs, by and large, have been the standard deployment method in most environments for storage for almost 15 years now, give or take, right? And that's even with flash storage or SSDs and NVMEs and all that stuff. So the storage inside the SAN has changed, but as a method, it's been a thing. Now, and I have a slide on this upcoming, you've probably heard the term hyperconverged, and I'm going to talk about that, so I'm going to couch that discussion. But but the funny thing is, in all this, those of you about 5 or 6 years ago, and they got bought by another company, I believe it was SanDisk. A lot of you may have implemented Fusion IO cards, because SANs, as great as they are sometimes hard to scale up ops when it's very much shared by everything that's used by everyone, right? So scaling it up didn't work, so we went back to local storage, and people are still using local storage. Some people are just putting really fast NVMEs in their servers. This is great for things like availability groups, right? We don't need shared storage. We can just have really fast storage inside our servers, fast networking, and everything just works. Where are we going? Things like PMEM are going to change the picture, but we don't know what that's going to look like 3 years from now. So we'll see. But I'd say certainly PMEM is going to be transformative. I just don't know what our physical architectures are going to look like, and will things like standard SSDs take over, and will spinning rust or our hard disk drives go away? Don't know. I want to talk about HCI for a minute, or hyperconverged, because this is where your virtualization platforms are sitting today. VMware makes a big push around vSAN. And reality, though, is not everybody's doing this, right? But the idea of hyperconverged is that your compute, storage, networking, and the whole bit is a very small, it is a whole sort of interconnected system, and everything's aggregated, like your storage is aggregated. It's kind of interesting. It's basically telling your SAN administrator they're no longer necessary. And it's just an interesting paradigm. You can use NVMEs, you can use PMEM. Like if you're using storage spaces direct, PMEM could be your caching. So hyperconverged is really cool. But if you're not doing physical, and you're up in the cloud, something like hyperconverged is not for you. So hyperconverged is very much a physical concept, okay? Let's talk about availability and sort of transition. So we've talked about the platform where networking, storage, compute, all that matters for availability, because that stuff isn't reliable. The other stuff isn't going to work. Now, clustering has been the platform for Windows since the late 90s, since the Wolfpack days when I started working with it. It's gone through some name changes. Those of you who know me know I'm very pedantic about this stuff. Some of you might be chuckling right now. But we started with Microsoft Cluster Service, which some of you might see as MSCS. There are some vendors who still use MSCS. It hasn't been a thing really near 20 years now, almost the entire length of past the organization. In Windows 2000 Server, it was sort of that last version they used MSCS-ish. And server clustering really became a thing in 2003, towards the end of 2000. And then, much to my chagrin, kind of like with Always On, Windows folks decided to call the availability feature in Windows failover clustering. Now, the actual cluster itself is called the Windows Server Failover Cluster. The actual cluster isn't a Windows Server Failover Clustering. Again, pedantic Allan. But to differentiate it from what SQL Server did, because that was always called failover clustering, that's why you call the Windows side of WSFC and the SQL Server side of FCI or failover cluster instance. And we'll talk about SQL Server here in just a moment. We've really grown to from just being able to support 2 nodes. Now we can have OS Max, which is 64, but let me tell you, from a general perspective, you don't want to be deploying a 64-node Windows Server failover cluster, because that would suck from a manageability perspective. We can now have Windows Server failover clusters that don't require Active Directory. It's really usable in Windows Server 2019. We can even create availability groups that don't use not only no domain, but no cluster. It's kind of interesting. Windows Server failover clusters with no domain or Active Directory DS it's sort of introduced in 2012, not really quite usable. 2012 R2. They fixed a few things in 2016, but 2019, like I said, really usable. Cluster validation to me was the most transformative from a Windows Server failover cluster perspective, because prior to that, we had to have a certified solution. You have to look on the hardware compatibility list or the Windows Server catalog, and that made it hard for everyone. But running the validation tool, which is built into Windows Server 2008, really huge change, and had an impact on SQL Server, because if you didn't pass validation, you couldn't deploy an FCI, and with an availability group, it's what told you if you had a good cluster underneath it or not. Now, what many people actually don't know is in Windows Server 2008, the clustering folks actually recoded the entire feature. Other things that have changed, starting in SQL Server 2016, really with 2017, but they backported it fully. It was partial support in 2016, which is why I'm kind of eliminating that, so there's a bit of an asterisk there. We can use DTC with availability groups. Now, the reason I put it here, not on a SQL Server slide, is that DTC is a Windows function, or feature, I should say, that took a joint effort between SQL Server dev team and the Windows Server dev team, and because it's an OS thing, I put it here. A big thing is, for me, is if you're using Windows Server 2019, or you want to deploy, shall we say, a Windows Server failover cluster for an availability group on Azure. In Windows Server 2019, we got the distributed network name, which allows you to not have to do the load balancer for the Windows Server failover cluster. I'm hoping they implement it for things like the listener later. And finally, there have been a lot of improvements to Quorum. I'm not going to talk about all of them, but the two that I really want to mention there are dynamic witness. So at a bare minimum, you should be looking at really Windows Server 2016 from a supportability perspective, but if you have to go older, do not implement an OS for SQL Server older than Windows Server 2012 R2. Because for me, that was a transformative thing from a quorum perspective. And Cloud Witness is awesome. It's only Azure, but it's basically file share witness put up in the cloud. So if you've got a multi-site scenario, you can have your witness be up in the cloud and you're not worried about where we sticking the witness. So I love Cloud Witness. Now let's switch gears to SQL Server. I've talked about infrastructure. I've talked about Windows Server, a bit of where we are, where we were, where we are, and where we're going. But now let's talk about SQL Server for the last portion of this talk. And again, similar to the Windows side of the house, I've got the 20-year view of SQL Server. And with SQL Server, most of you are more familiar with this picture, but we've had a lot of releases, clearly, right? And if we look at the entirety of it, again, I know Microsoft's making their big push around SQL Server 2008, 2008 end of life. And we're going to talk about why upgrading and things like that are a little bit harder these days. But I would say most of you are probably sort of in the mid to upper of that range where you have a mix of mainly, I'm not saying you don't have things older or newer, probably 2008 through 2016, right? Now, some of you may be asking yourself, Allan, why isn't there SQL Server 2019 on here? It's not officially released yet. So we don't have an official release date. So I'm not going to put it on here just yet. When it's released, I'll add it. Okay. Oh. So let's talk a bit about the history of where we've come from. From my perspective, the most fundamental availability feature in SQL Server is backup and restore. Back in those days, we actually called them dumps. And I believe the dump syntax, while deprecated, you can still sort of see in SQL Server. I haven't tested it in a while, but that was in the first version that I used on Windows, which was 4.2.1a. Okay, that still had all this shared Sybase code. And let's just go back and mention something here for a second. Much like the clustering feature was recoded in Windows Server 2008, SQL Server was recoded from the ground up, in, let me choose red here, SQL Server 7. That's when they truly broke away from all the Sybase stuff. So it's kind of an interesting thing to think about, right? Like, SQL Server as we know it today wouldn't be the same if they hadn't done that. And there were even bigger changes, which I'll talk about in a moment, with SQL Server 2000. Replication, I don't always lump in with availability, but by and large, it is, in a way, availability. Also, again, was there from day one. And, when people talk about things like database mirroring or availability groups or even log shipping, people will call it replication. That's why when I talk to customers, I never assume, because they're thinking, they're not talking about replication of the feature, they're talking about the act of replication. Now, FCIs, or the clustered instances of SQL Server, were introduced back in the day, so a long time. Those people who had a bad experience generally had it, especially with, shall we say, SQL Server 7 for various reasons. A lot of that basically got fixed in SQL Server 2000, which is what I was sort of hinting at a moment ago, when we had the introduction of instances, right? And we had the ability to have better installs. Now, instances were a revolutionary concept because before SQL Server 2000, we couldn't install more than one installation of SQL Server on a server. Ironically, on Linux now, we can only have a single instance, or the default instance, of SQL Server. So we've come full circle there in a way. I don't know if they're going to be adding multi-instance capability. We'll see. Log shipping basically been around forever because it's just backup based on backup, copy, and restore. But it actually wasn't a feature, and the irony, and some of you may laugh, it was put in Enterprise Edition in SQL Server 7, and all of us scratched our head at that. In 2000, it was actually put in standard as well. But it was before that a free tool in the back office resource kit, for those of you that remember that. So it's always kind of interesting. Database mirroring came in Service Pack 1 of SQL Server 2005. It was lit up. Officially deprecated in 2012. If you look in books online, it was officially replaced. Now, please, and let me give you a plea out there. Please don't implement database smearing. Please, if you're using it now, really consider switching to availability groups. The feature in Standard Edition, they're calling basic availability groups, but let me just remove any confusion. If that's just a marketing name, it's just availability groups in Standard. There's nothing different about it in the way that it works. It's just basically restricted in the sense that you don't get things like readable secondaries. But by and large, it's the same as availability groups and its bigger sibling. So that's generally not a thing. Now, the reason I mention this is because Microsoft used to have a policy of deprecation where generally in N+2, after it's deprecated, they remove the feature. They're generally these days no longer removing features. So it's still there, but it's officially deprecated and replaced. So I wanted to talk about that. And obviously, the big one these days, especially we're doing non-shared disk type architectures, is always on availability groups. Not going to get into the whole always on thing today. Sorry for those of you that are hoping for hearing a rant from me. But to me, one of the more significant changes to availability groups is the distributed availability groups variant that we got in SQL Server 2016, which allows us to do DR a lot better. I have talks out there on this. I've done it, I believe, at PASS Summit, so you can look up on the web, on YouTube probably, and see a talk from me on this. We don't have time for me to go deep into all the variants now that we have of availability groups. So what are some of the trends I've seen over the past 20 years? First of all, it's funny. We have a lot of features. A lot of things have changed from a technology standpoint. But the things I find that are always wrong are people and process, and things like not being willing or having the money in some cases to spend to deploy what's right. Not updating your software, because if you're not applying updates, you can't be mission critical. If there are bug fixes, you have to take downtime, because the longer you wait to take change, there's more risk. So it's all that sort of non-technical stuff that makes availability, and it's still true today, and it's still going to be true 5 years from now. Look at all the recent examples of outages. I've got examples on my site in blog posts around stuff recently, whether we had the Wells Fargo thing, all the data breaches that we've had, the BA stuff from the past few years, BA meaning British Airlines. You know, if you have people doing stupid things and taking you down, I don't care what technology you implement, no feature is going to take care of it for you. And the other thing is, there's no one size fits all when it comes to these things. For example, FCIs are instance level protection, meaning everything fails over to the other server, whereas availability groups are database level protection, meaning everything inside the database is your essentially container, if you will. So everything that sits outside that has to be taken care of by you. And that, some people, they don't like that, but it is what it is, right? But that dictates, that goes back to sort of what I have there in the first bullet point. If you need to understand your requirements, and again, I don't care whether you're doing it on-premises, virtualized, the public cloud, all that stuff needs to be right. And that's never going to change. I saw it on when we were doing cluster in a box. I see it when we're spinning up VMs up in AWS or on Linux, where you have pacemaker instead of a Windows Server failover cluster. None of it matters, because all that stuff is the same. Now, one thing I have seen that's changed, and our lovely moderator and I were having a discussion about this in the pre-show, is that FCIs have become a bit passé. Now, coming as a guy who wrote the white paper in 2000 and written a lot of things, and I'm known as a clustering guy, what FCIs are really kind of no longer a thing, even though people do it in virtualization in the public cloud. Why is that? Really simply put, VMs don't fail generally in the way that physical hardware used to fail. So having that failure generally happens at a much lower layer, and there are other things you can do, right? It's also harder with the shared storage to implement in virtualization or up in the public cloud. So by and large, there are use cases. I've done it with customers. And we were talking about some of them earlier. For example, if you have databases that require simple recovery model, that's one use case. But yeah, by and large, FCI is a bit more passe. There are use cases if you're doing especially physical, but outside of that, maybe not so much. Coming up, we've got things like Kubernetes, so in 2019, we have availability groups using Kubernetes and K8s. That's awesome. But the thing is, whether it's Kubernetes or Pacemaker or Windows Server failover cluster, the reality is clusters inherently are going to add a little complexity, right? So it's just something else you have to manage. It's part of what we do. It was there in 1999. Kubernetes is just the newest form of adding another layer in, a clustering layer in. So the funny thing about availability is in 20 years, a lot of our architectures have changed, maybe location from physical to virtual to cloud, but availability has by and large stayed the same in a way. So where are we going? I just mentioned Kubernetes and containers. I think containers are going to be hot. I mean, you're hearing a lot right now. Traditional dyed-in-the-wool Windows Server shops aren't changing tomorrow. Right now, SQL Server does not have support for a Windows-based container. I'm hoping that comes in the near future. We'll see what happens. Right now, it's all Linux-based. Containers come from a world where there's a lot of Linux development. That's where a lot of things are done today. And it's the way a lot of things have been done in the Linux world for a while. So I think where we are with containers today is where we are with virtualization 10 or 15 years ago. But I would say the story is going to be very different in 3 to 4 years. Containers can become pretty normal, even for us folks that are used to doing server stuff. As I've mentioned a few times, features have changed, but how we do things hasn't changed a lot. Availability groups are still a thing. They're mature. They're 7 years old, plus years old at this point. And we're now doing them in Kubernetes, so that'll extend its life another 10 years. So we don't have to relearn everything as SQL Server, folks, but how we deploy it and how we learn how to deploy it's going to change. From a physical standpoint, hyper-converged, hybrid solutions where we're bridging on-premises and the public cloud, that's going to be really huge because that's most people's foray into using the public cloud. Not everybody is just jumping in. And by the way, that picture right there is from sort of my collection of sticks. It is the promo paperweight for the album Crystal Ball from 1976. Now, other stuff, we've only got a couple minutes left. I get this question a lot, and I felt this is a great talk to address it. Windows Server is not going away. Just because SQL Server is heavily invested in containers and Linux-based containers now, and we've got 3 distributions that's supported with SQL Servers 2017 and 19 now, Windows Server is not going away. So you can rest easy. You'll hear a lot about software-defined data center, software-defined networking. That's a big part of all this hyper-converged stuff. That's what basically is happening up in Azure and AWS. All that software design stuff is here to stay too, but it's just networking and storage and all the stuff that we're familiar with, just giving it a different name, right? Now, this is the thing I was talking about earlier. In terms of OS and SQL Server, and when you upgrade it, if you have a VM or you're up in the public cloud, here's the thing. We used to tie upgrades and OS stuff to physical server deployments. Every 3 to 5 years-ish, we do a new OS, new SQL Server version, roughly, when we replaced hardware. What's the compelling reason to upgrade now when you were virtualized? Well, a bit beyond the scope of this talk, but I'm just putting it out there, and I think that's why we still see a lot of things like 2008. And the case gets harder and harder if it's just working. So kind of interesting. And even up in the public cloud, which I haven't touched on a lot in this talk because we all kind of know it's there, right? You're buying capacity, so things like baselining and benchmarking really matter. If you really stink at it today and you don't do it, you're not going to be able to effectively deploy in the cloud or be available or get the performance you need because everything's based on consumption and getting the right size disk, things like that. And finally, just so you know and are aware, Microsoft now is just releasing cumulative updates from now on out with SQL Server 2017. No more Service Packs. SQL Server 2016 is the last one. So those of you that are part of the Wait for Service Pack 1 crew, time to update your skills. I've got a bunch of links here. I'll leave this up while I have the questions about things like the Intel Optane stuff, going beyond 64 CPUs on Windows, things like that. A link to the Intel Optane and what they talked about this week around the PMEM stuff that I mentioned earlier. And with that, we have about 2 or 3 minutes. Let's open it up for questions.
Thank you, Allan. Great presentation. Yes, we have a couple of questions. One of them, the first one, you kind of answered it a little bit, but the question is, with the improvement of SQL Server's availability groups and the fact that Azure SQL HA is built around HEs, are SQL FCIs now dinosaurs?
I wouldn't say they're dinosaurs, but like I mentioned, there are use cases for it, but it's increasingly harder to make that case. I implemented one recently up in the public cloud using Sios Datakeeper, but for a customer, but case by case scenario. They're not going away. They even implemented them on Linux, but sometimes harder if you're not in a physical world.
All right. So the last question is virtualization using full-blown VMs old school now that we have virtualization using, oh, sorry, it was more like a question. It's more pointing like if Azure or the cloud is using VMs, does it make sense to keep using virtualization now that the cloud is full-blown on VMs?
So that's a great question. So first, let's really quickly talk about the cloud. There are two things. There's IaaS, which is infrastructure as a service, which is VMs, and there's PaaS, or platform as a service, Azure SQL Database, RDS in AWS, Azure SQL Managed Instance, stuff like that. Now, in terms of, I've actually been saying this for a while. I didn't say it earlier, but sort of if you're just getting to virtualization now, to this question, you're a little late on the adoption curve, and we're on several, I would say, the backside of it. The cloud with IaaS especially, it is a hypervisor running underneath it. You're using VMs, that's IaaS. But really where things are going is more the PaaS world, where do you really need a whole VM? Do you want to manage Linux or Windows Server, right? So it's not even so much that is Azure or IaaS the future, but is PaaS the future? And I would argue in 5 years from now, PaaS is going to be a much more attractive option for folks who are looking to sunset physical and virtualized servers and even IaaS, because a lot of the platform underneath is taken care of for you. Things like availability, all that stuff is built in. So it's not just virtualization that isn't necessarily an endangered species. Now it's extended itself up to the cloud. Look at what VMware did with their VMware Cloud on AWS. They basically extended ESXi up to AWS. So virtualization still has life. Let me be very clear. And IaaS still has life. But I think the future for most folks is going to be PaaS.
All right, perfect. Can you move to the next slide, please?
Absolutely.
Thank you. All right, so please stay tuned for our next session, Baselining and Alerting for Microsoft SQL Servers with Kevin Klein and Richard Douglas.
Which dovetails exactly the way I ended my talk, because I think that's an important aspect of SQL Server. I'm sure it'll be a great talk.
Definitely. Well, thank you, Allan, and thank you all for attending. Goodbye.